Mr. Collier, and today we're doing discrete random variables. Okay, discrete is the opposite of continuous. We saw this in statistics. This means well, usually whole numbers, but it's not a range of data. It's like well, basically we have usually whole numbers, like a dice roll. In a dice roll, we have the possible outcomes are 1, 2, 3, 4, 5, 6. There's not an infinite number of possibilities, so this is discrete. If you're talking about heights of people or something, there's an infinite number of possible heights, and that's continuous. So we're just going to talk about discrete today. Um, and yeah, let's use the dice rolls as an example. So there's 6 possibilities. No, 1, 2, 3, 4, 5, 6. Each probability is 1/6, right? And we say this probability capital X equals little x goes in this column. Capital X is the discrete random variable for the outcome of the dice, and little x is each. This should be little x, right? This is little x1, little x2. Okay, so each of the outcomes are labeled little x, but the discrete random variable we use a capital X. Okay, as it says here. Each value has an associated probability. Okay, so this is the notation. So the probability, x equals 1 in our case is 1/6, and so forth. They're all equal to 1/6 in dice rolls. This is kind of common sense, but all the probabilities have to add up to 1 because we listed every single possibility for the dice, and in any probability distribution, they all add up to 1 or 100%. Alright, so we're going to often see them in table form in exams, and that's what we're going to do right here. But let's generate the table. Okay, so this is probability x equals x, and yeah, so let's put these into the table. We have only 1, 2, 3 are the x values, and probabilities are yeah. So we're gonna solve for the value of k actually. So I guess we go back to this thing here. The sum has to be equal to 1. So k times, this is k times x is 1, so it's going to be actually 3k. And if x is 2, then we have 4k. X is 3, we have 5k. So I guess we could say we can add them together. 3k plus 4k plus 5k equals 1, and we get 12k equals 1. K equals 1/12. Okay, so then the probabilities are actually 3/12, 4/12, and 5/12, which makes sense. They all add up to 1. Expectation. We call it expectation. We could also call it the mean. So the expected value of like the dice distribution is the average amount on a roll. Okay, it's like it's a measure of the average, but it's called expectation or the expected value. Okay, so we roll a die 600 times. What would you get on average? We use this notation. Expected value is 600 times the probability, which is 100. Okay, and it works out this way because they're all the same. But technically, we use this formula here. This means you add up all the x values times the probability of x occurring. Okay, so that is going to be, so the expected value for one dice roll would be 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 all the way up to 6 times 1/6, because those are the probabilities of each of those numbers occurring, right? So 1/6 of the time you get a 1, 1/6 of the time you get a 2. Anyway, if you add all those up, we just do 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 21. And you're going to have 6 as the common denominator. that's 7 out of 2, or 3.5, which makes sense. That's the average dice roll. So the expected value when you roll a die is 3.5. Okay. Okay, let's take a look at some examples. A spinner is divided into 4 equal parts. 2 of these have a 3 on them. Oops, should have read that first. Find the expectations. So there's only 3 possibilities. 1, 2, 3. And the probability here is a quarter, and this one's half. So the expected value is, we just multiply all of them together. 1 times a quarter plus 2 times a quarter plus 3 times half. Maybe you could have left it as 2 quarters to make it easier for yourself. Okay, so they're all at a quarter now, and we got 1 plus 2 plus 6 is 9, 9 over 4, which equals 2.25, if you will. So the average spin is 2.25. Okay, and this stuff is used in insurance companies all the time to calculate your insurance policy, the amount of your insurance policy. An insurance company sells term life insurance policies for a 20-year period. The amount payable if death occurs is this. The company's actuary has calculated that the probability of death of a 30-year-old man over the next 20 years is this. So that's the probability. Find the suitable premium for a policy. And that the suitable premium for the policy is $2,000. So this is how much you have to pay. What is the company's expected gain? Okay. So basically, if death occurs, the company loses $75,000. Call that a negative number times the probability of that happening. And then this is how much they're gaining per policy. Okay, 2,000. So there's a small chance to lose 75,000, but they're definitely gaining 2,000. So this is the calculation for the expected value. And that works out 725. Okay, so we're actually gaining money on this policy. Okay, let's see. Mean, median, variance, and standard deviation. Yes, so we need to know all these. Mode is the value with this highest probability. For the dice rolls, all the probabilities were the same. They're all 1/6. Okay, so they're all the mode, I guess you say, or there's no mode. But sometimes some things are more likely, like in the spinner. We had one outcome that was more likely, so that was the 3. 3 is the mode. So the most likely outcome is the mode. The median is the value of m such that, you know what the median is for the dice roll. It's just in the middle, so you can call it 3.5, but it's going to be different for some distributions. Okay, now the expected value and the variance, I believe these are, there's formulas in the formula booklet for that. It's a little bit confusing to read, but let's look at this one with the sum signs. This is basically for discrete, and this is for continuous. The thing is, this is how you calculate it, but the more useful version is on the right, actually. Okay, expected value is actually here. No, not there. Where's expected value? Oh, we just did the expected value, but the variance is here. This formula here, you do x squared times the probabilities, and then you minus the expected value squared. Or maybe you can see it better here. Expected value of x squared minus expected value squared. So we're going to use that in a second. Okay, let's look at the 6-sided die and check out the variance and the standard deviation. Okay, so the formula for the booklet is expected value of x squared minus expected value of x squared. Okay, I'm going to put a sigma there, but that's actually just e. And recall we have 1, 2, 3, 4, 5, 6. And they're all 1/6. This is probability x equals x. So the expected value, let me just go back up a second. Did I write this x squared? I kind of wrote that wrong. Okay. So first of all, let's get the expected value of x. Actually, we did that above. It was 3.5. Expected value of x squared means you do x squared times the probability plus 2 squared times a quarter plus 3 squared, so not a quarter, sixth, times 1/6. Okay, now they're all out of 1/6, so it's like 1 squared plus 2 squared all the way to 6 squared over 6, right? So let's work that out on the calculator. Let's make a fraction, okay. So basically 1 plus 4 plus 9 plus 16 plus 25 plus 36 divided by 6 is 15.2, or maybe you can write it as 91 over 6 to be exact. 91 over 6. Okay, so the variance is, we do that number, 91 over 6, minus the expected value squared, which was 3.5, or 7 over 2 squared. So we take this number on a calculator, subtract 3.5 squared, I guess. And we get this number, maybe as a fraction, 35 over 12. Let's write both. 35 over 12 is exactly it, but if we write as a decimal, 2.92, we can see that the variance is 2.92. Of course, that means the standard deviation is the square root of 2.92. So to get that, yeah, let's just do square root of the answer from before. Oh, oops. So it's 1.71 is standard deviation. Okay, next, number 2. This is a very common type of question where we have missing values in the table and we got to figure it out. And the key here, I guess you can make 2 equations, because remember, all these probabilities have to add up to 1. So P plus Q equals 0.4 if I subtract these. But also we're given expected value equals 4, so you can make an equation out of that. That means 1 times 0.2 plus 3 times 0.4 plus 6p plus 8q equals 4. And this is, what is that there? 1.4 plus 6p plus q, 8q equals 4. 6p plus 8q equals 2.6. Okay, let's practice solving this with our calculator. I suppose we could do it by hand, but let's go on the calculator and we go to apps. You can do this on Linear Solver. I'm going to change it to 2 by 2 and type in the coefficients. We can type in 1, 0.4, 6, 8, and 2.6. Okay, you get answers 0.3 and 0.1. So P equals 0. What was that again? 3. Q equals 0.1. We could also do it by hand. We can just simply multiply this equation by 6. We get 6p plus 6q equals 2.4. Subtract, you get 2q equals 0.1. You get q equals 0.1. And then solve for p. P equals 0.4 minus Q, so P equals 0.3. But it's important to be able to use your calculator feature as well.